Hi all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. In the previous lecture, we were discussing about the generalization problem under machine learning basics. Now, let's see the generalization problem. So, imagine or recall that we have seen two students. Student 1 who memorized the answer word by word, wherein the second student understood the concepts very clearly and he prepared for the test. So what happened was during the training test, both the students performed well and got 99% accuracy. Whereas during the final examination, that is when the new questions were asked, what happened was the student one failed, whereas the second student succeeded. So in the same way, our machine learning model should not also work. That is, our model should have low training error also as well as low testing error. That is, it should perform well on both the cases. So that is how our machine learning model should be designed. Let's understand why do we need machine learning model. Suppose you are given a task of filtering the spam filters. So when you do a spam filtering and a manual featuring, what you do is you write thousands and thousands of codes or the rules. If you see this word, it is a spam. You also tell the model that if you see this pattern, then the spam is there or not a spam. So what you do is you write thousands of codes or thousands of rules when you do it manually. So what are we going to do is instead of doing it manually because there may be mistakes. So what we are going to do is we are going to make a model. So we all know that in machine learning model we have supervised, unsupervised and reinforcement learning. Let's take an example of supervised machine learning model for this spam filtering. So what it does is here we will be giving lots and lots of examples like emails, images. So the input data, it will be fed to the machine learning model. So by understanding or learning from the input data, our machine learning model will give the output as whether it is a spam filter or not a spam filter. So in the supervised machine learning, a model learns by the way a mapping is done. For example, if f of x tends to y. So wherein x is called your input or the model parameters, whereas y is called your output or target label. So instead of doing any feature manually, what we are going to do in a machine learning is we are going to make a model to learn from the data what is being given as an example so as to predict the output. Let's see what are all the factors that affects our machine learning model performance. The first one is the amount and quality of data. So we have to be very careful in feeding our amount of data that we are going to feed and also the quality of data what we are going to give to the machine learning model. The second one is the model capacity. So model capacity is nothing but the ability of the machine learning model, that how it learns from the data is called model capacity of the machine learning model. So it should be not too simple, not too complex. So when it is too simple, when the model capacity is too simple, we call it as underfitting. So when it is too simple, what does that is? It fails to learn patterns. So if it fails to learn pattern, what happens is a high testing error and a high training error is possible in too simple model. Wherein if you take too complex model, what happens is the model, it memorizes the training data. So here there will be high error during testing, whereas low error in training. So this pattern is called overfitting model. So we have to generalize both these concepts very well. So we need to balance the complexity for the model's best performance. So I told you no, what is model capacity? So the model's ability to fit a wide variety of functions or complex patterns. That is the ability of the machine learning model is what we call a model capacity. So if it is low capacity, it means a simple model like linear regression. When we represent high capacity, we may represent deep neural networks, which is high capacity and it is also flexible. When you talk about median capacity, it is like your decision trees. Thank you.